going to do is look at the properties of quadrilaterals. So the first property we're going to look at is that the angle sum of a quadrilateral is 360 degrees. So for that reason, you can just work out theta, which is 360 minus the other three angles. Okay, 89, 72, 61. And then what you're going to do is to use your calculator. Okay, work this out, and then 138. 138 degrees. Okay. All right, let's move on. All right, next we're going to look at some definition of parallelogram and trapezium. What's a trapezium? A trapezium is a quadrilateral with at least one pair of opposite sides parallel. So that's a trapezium, two sides parallel to each other. Whereas a parallelogram will have exactly two pairs of sides parallel. Two pairs, one pair, the second pair. Okay, good. So that's the differences between them. And because the parallelogram has got two pairs of sides parallel, we have four properties. So these are the four properties which you need to memorize, not on the formula sheet, memorize. Memorize. Okay, good. I just drew a heart there. Okay. So, which is a good way to memorize, because when you memorize, you think of it in your heart. Okay. Okay, good. So let's highlight this. So these are the four properties. Now let's look at these, and they are not hard to remember. Opposite sides are parallel. That's the definition of parallelogram. Opposite angles equal. Opposite sides equal this. So there are basically three things that has opposite in it: opposite sides, opposite angles, and opposite sides again. And then the last one is diagonal bisect each other. It means if I draw two diagonals, a diagonal is a line that connects two vertices inside the shape. Another diagonal, these two lines, they cut each other into two equal halves, right? This means bisect each other. So four properties you have to memorize. And we're going to use these properties to answer a few questions about parallelograms, which we can find on the next page. Okay, let's go to the next page. So for each of the following, find the value of the polynomials, giving reasons. So what property do we use to find the length of the missing sides? How do we find y? Y, yeah, diagonal dissect. So y equal to 7, diagonals dissect in parallelogram. Okay, what else are there? There's another polynomial we're going to find. X plus 6 equals to 3x. So 2x equal to 6. Therefore, x equal to 3. Same reason. Diagonals bisect. Diagonals bisect. Okay. Alright, so y equal to 7, x plus 6 equal to 3x. So diagonals bisect. So x plus 6 equal to 3x. Alright, good. Continuing on. So these two sides are equal. These two sides are equal. In a parallelogram. In parallel. Oh. Oh, good, done. How about the next one? What reason could we give? What reasons? Opposite angles equal. So you say 3x minus 10 equal to 2x equal to 2x plus 50. And you give a reason. Opposite angles are equal. Opposite angles are parallelogram. So you say opposite angles of a parallelogram. Okay, so what do? We just solve this. So subtract both sides by 2x. And you end up getting x minus 10 equal to 50. X equal to 40 is 60. Right, done. So they're pretty easy once you know the properties of the parallelogram. Okay, good. Once we do this, we can then find more things. We can look at the next shape, which doesn't look like a parallelogram, but in fact there are two parallelograms in this figure. So let's highlight this. There's one here, that's a parallelogram. And there's a second one, there's another parallelogram. There's two. Oh, purple and yellow become red. They actually change color. Okay. Alright, okay, good. I know that yellow and blue becomes green. Let's see if it works. Let's check that. So blue, does it become green? They are red, sort of green. Yeah, it's green. Yeah. Alright. Okay, good. Let's move on to do some work. Okay. Alright. So what we're going to do is to find out the missing sides. There are angles we have to work out, and sides we have to work out. Let's start with the sides. What's the value of x? X equal to 5 because the opposite sides, you can write OPP because that's a shorthand for opposite. Opposite sides of parallelogram. But parallelogram, write the full word because there's no shorthand. Okay, good. And then to get the next one, now x is 5. How do I get y? What would the reason be? Y won't be opposite sides because I don't know this side, but we know there's an isosceles triangle, isn't it? So we say y is equal to 5 because the base angle are equal. So if they're both 68, therefore y equal to 5. Sides of isosceles. Okay, good. What else are there? Now, every time you find something, label it on a diagram because that will be useful for the next part. And there's two angles we're going to find. Okay, who can suggest how to find alpha or beta? And give valid reasons. Anyone? That was quick. Okay. Anyway, alpha. Let's start with alpha. I think alpha is easier to find. You want to suggest alpha? Anyone? No? I'll give you a clue. Look at this parallelogram, the one in purple. Opposite angles, see they're both 68. Right? Oops. They're both 68. They're opposite. So write alpha equal to 68. Opposite angles of parallelogram. Okay, thank you. Alright, thanks. Alpha, look like a fish, alpha. Angle to work out. Who can tell me how to find beta? Of which one? There's nothing opposite to it. No, use this way. They're parallel, right? What do we know about these two angles? What do we call this? corresponding. So write beta equal to 68, corresponding angles. Yes, on parallel lines. You have to include the word on parallel lines. Alright, all good. So we done it. Good. We did it. Alright. Okay, after we looked at the properties of parallelogram, we need to look at some tests for parallelogram. Just like there are tests for similarity, tests for congruence, there are also tests for parallelogram. So there are 5 tests because there are 4 tests altogether. These tests are very similar to the properties of parallelogram. Let's look at these. To prove it's a parallelogram, prove the opposite sides are parallel. That's the first test. Or you can prove the opposite angles are equal. That's the second test. The third test is to prove the sides are equal. Opposite sides are equal. And then there's a fourth test. This test combines the parallel and equal. But you only have to prove 1 pair rather than 2 pairs. Note the difference? So these are 2 pairs, 2 pairs, 2 pairs. But this is 1 pair, but you have to prove 2 things, both equal and parallel. Whereas the other one, you have to prove 2 pairs, but only parallel, or only opposite angles equal, or only 2 pairs of sides are parallel or equal. Okay, and then the 5th test is the last property of the parallelogram is that the diagonals bisect each other. So if you can prove they bisect each other, then it is a parallelogram. So there are 5 tests. Okay. Okay. So we're going to use one of these tests to prove whether the following shapes are parallelogram. And you have to mention the correct test when you do it and give the right reasons. So we're going to look at example 35A. Now, which test would you say to say that this is a parallelogram? Which test would it be? Opposite sides are equal, yes. So you should give some reasons. Just say AB equal to BDC equal to 5.3 given. And the other one, AD equal to BC equal to 3.8 also given. And then what do? We say, therefore, ABCD is a parallelogram. Give a reason. Parallelogram. Yeah, you have to write down the test. So the test you say is opposite sides are equal. Equal. So when you prove opposite sides are equal, it is a parallelogram. Okay, done. All right, think about which test to use for the next one. Yeah, the 4th test, isn't it? This one, just 1 pair. See, this one, I do 2 pairs of the same thing, or you can do 1 pair of 2 different things. Okay, so let's write it down carefully. So we have to write down AB equal to DC given equal to 7 cm given. And then you also have to say they are parallel as well. Oh, it's meters. Oh, 7 meters. Okay, and then you say AB parallel to DC. And that's given as well. And then you say, therefore, ABCD is a parallelogram. What reason do we give? 1 pair of sides. 1 pair of sides, both equal and parallel. Okay, done. So I need to know these tests. Alright, there's 2 more you can write down. See if you can write the correct test. Next one's a little bit tricky. See if you can work out. And then we've got other shapes as well. Okay, done. Let's move on. Next page. Now look at this one. Now this one already have one pair of sides parallel to each other, given. So you have to decide on what test to use. What else should I prove? I need one more piece of information. You either prove xm equal to yn, one pair of sides both equal and parallel. What's the other option? Prove the other pairs. Oh, prove opposite angles are equal. But you have to find the other two angles. Actually, we can do that. Maybe that's an easier way. But then I think it's so there's more than one way of doing that. So you can prove opposite angles equal, or prove opposite sides are equal, right? So only got two sides are parallel. How do I prove? Say again. Yeah. Oh yeah. Oops. Parallel. So how do I prove these two sides are parallel? What are the tests to prove sides are parallel? What do we call these two angles? And what do they add up to? That's it. So therefore they are parallel. Okay, so you say angle YXM plus angle NMX equal to 54 plus 126, which is 180 degrees. Which you can conclude XY is parallel to MN, where interior angles are supplementary. Alright, good. So we did that. Okay, good. Once we do this, we can then say something. We then say it's a parallelogram. Therefore, X, M, and Y is a parallelogram. Opposite sides are parallel. Okay, are parallel. So not are parallelogram, are parallel. Right, done. And alternatively, it can also prove opposite angles are equal by finding the sides of these two angles. So if I use method 2, you can work out these two angles by co-interior angles as well, and prove opposite angles are equal. So you can prove that's 126 by 180 minus 54, because these two sides are parallel. You can prove this is 54. Once you do that, you can prove opposite angles are equal. Therefore, it's a parallelogram. Now, you can use a shorthand here, but not when you say are parallel, because it can be confused with R11. So when you say are parallel, use the word. But when you write it here, XY parallel to MN, that's okay. Use the parallel symbol. Okay, next, let's use the next one. What test would you use? That one's obvious. We got the two diagonals, and they're equal, isn't it? They bisect each other. So we say, what do we say? We say AE equal to EC equal to 5 cm given, and then you got DE equal to EB 6 centimeters also given, and you say therefore ABCD is a parallelogram. Given reason, diagonals bisect each other. Okay, done. Okay, after these examples, hopefully you're more confident with the properties of the parallelogram and the test of parallelogram. And then we're followed by two examination type questions. So the next one, be hard to prove it is a parallelogram. And then we'll look at other shapes like rhombuses and rectangles, and then squares. Alright, let's do this. Prove AYCX is a parallelogram. How do I prove? Now notice that we already have two sides are parallel. We just have to prove these two sides are you have to prove these sides also equal, or prove these two sides parallel as well. Okay, let's start with the obvious. So prove AYCX is a parallelogram. AYCX is this one, right? Now how do I prove it? We say CX is parallel to YA. Y is a parallel because we're given that's a parallelogram. Actually, we write something else first. We write since AYCX is a parallelogram, therefore CB is parallel to DA. Opposite sides of parallelogram. Oh no, sorry, ABCD. I wrote the wrong things. Thank you. So it should be ABCD is a parallelogram. ABCD. Therefore, CB is parallel to DA. Opposite sides of parallelogram are parallel. And because that's parallel, therefore, CX is also parallel to YA. So they are parallel because we use the fact that it is a parallelogram. The bigger sides are parallel, so the overlapping sides must be parallel as well. And then once we do this, we can then try to prove they're equal as well. How do I prove they're equal? To prove they're equal, what you do is you're going to say something like this. So we're given these two are equal, isn't it? So we say XB, actually we say this, BC is equal to DA, opposite sides of parallelogram. Okay, so the two long sides are equal, but we're also given these two shorter sides are equal. The XB is equal to DY given. So if you subtract them, BC minus XB is same as DA minus DY. Subtracting equation 1 by equation 2. So subtract these two, and once you subtracted them, BC minus XB equal to CX, right? BC minus XB equal to CX, and so is AY. So prove that they are both equal and parallel. So we prove they're parallel and equal. So you say therefore AY CX is a parallelogram. Parallelogram. And what's the reason? One pair of sides, both equal and parallel. Yeah, I mean, thank you. 24 minutes already. Thank you. All right, we're on page 22. Yeah, page 22. Yeah, he walks around like this. Yeah, you don't want to interfere people. All right, let's move on. So next one is a rhombus. What's a rhombus? The definition of a rhombus is a parallelogram with a pair of adjacent sides equal. So that's a rhombus. So it's a parallelogram except two sides are equal to each other. The properties of rhombus are given below. All four sides are equal. Diagonal bisect each other, but at right angle as well. That's the extra property. And the diagonal bisect the vertex angle. As you can see, these two angles are equal. Now, what are the tests for rhombus? The tests of rhombus are listed here. All sides are equal, and diagonals bisect each other at right angle. Okay, all right. And then the diagonals bisect each vertex angles. So these are the tests for rhombus. The most common test used in the exam is all sides are equal, or actually this one's also very used a lot. Diagonals bisect each other at right angle. But this one, the last one, are not really used that often. I don't think I've ever seen a question that uses this. But these two are used a lot. Particularly the second one, the diagonal bisect each other at right angle. You'll get a question like this in the exam to prove it's a rhombus. Okay, so that's a rhombus. Let's look at the rectangle. What's a rectangle? A rectangle is also a parallelogram, but with one angle at right angle. See the differences between rhombus and rectangle? They're both parallelogram, but for rhombuses, the one pair of adjacent sides are equal, whereas the rectangle, just one angle is a right angle. And let's look at the properties. All four angles are right angle. The diagonals are equal and bisect each other. And the test for rectangles are all angles are equal, all diagonals are equal and bisect each other. Okay. Finally, we have the squares. A square is a rectangle with a pair of adjacent sides equal, which is there. Now, how do I remember all these properties? This is what we have to list the property in this diagram. Summary of all the quadrilaterals. So let's start with the parallelogram. We've got opposite sides are equal. Opposite sides are parallel. Opposite sides parallel. And then the next one, opposite sides equal. And then we got opposite angles equal. And the last one is diagonals bisect each other. Okay, diagonals bisect each other. So what we do is we do this. These are the four properties of parallelogram. And for rhombus, you will have all the four properties because this is a parallelogram plus three additional properties. And the three additional properties are all sides equal, all sides equal, diagonals bisect vertices, and also diagonals perpendicular to each other, or just say diagonals bisect at 90 degrees, like that. So the rhombus has three extra properties plus the four properties above. Four properties of parallelogram plus four properties. Okay, like that. And then for a rectangle, like before, it has all four properties above, plus the two more. Okay, so let's write them down. So the rectangles has four properties, plus two extra ones are what are they? So you have all angles 90 degrees, and then the diagonals are equal. Yeah, I should write this over here. Alright, so I should write this here for the rhombus as well. All four properties above plus these three additional properties. Okay, all right. Let's continue. How about a square? A square will have all of properties of rectangle plus rhombus. That's how I remember all the properties. So if you remember this flow chart, then you can remember all the properties of the quadrilaterals. So a parallelogram has 4, a rectangle has 4 plus 2 additional ones, the rhombus have 4 plus 3 additional ones, a square will have everything. So a square is a perfect one. That's everything. Okay, good. All right, now we're going to do some examples on this. Let's do some examples. Now, before I move on, notice that the 3 extra properties of rhombus doesn't apply to rectangles, and the 2 extra properties of rectangle doesn't apply to rhombus. Okay? Okay, let's move on. Oh, it's a long lesson. We went through a lot. Okay, let's look at this. So in this question, what shape is this and how do we know? How do I know what shape it is? What shape would it be? All sides are equal, so what shape would it be? Good. A, B, C, D is a rhombus. How do we know all sides are equal? That's one of the tests for rhombus, isn't it? All sides are equal. And because we know it's a rhombus, then we can use the property. Therefore, how do I find these 2 angles? What do we know about these 2 angles? They are, what's the properties of the rhombus? Let's have a look. Diagonals bisect vertices. So what does that mean? They're equal. So you say 4 alpha minus 1 equal to 3 alpha plus 8. Diagonals bisect vertices. Bisect vertices. And then we can work things out. So that will be alpha equal to 9. That was easy. Alright, try the next one. Alright, okay. How about the next one? So we're going to work out certain information. That's a square. ABCD is a square. Inside there's an equilateral triangle ABE. The diagonals AC intersect BE at F. Find the sizes of the angle alpha and phi. Let's start with alpha first, because I think alpha is easy to find. How do you find angle CAB? What would it be? Well, what do we know? It's a square. What do we know about the diagonals intersecting the vertex of a square? Bisect, isn't it? It's a properties of the rhombus. So we say that's equal to, and because that's a 90 degree, if you bisect it, that will be 45. So you can just say diagonals bisect vertex. Okay, so we've got 45. Let me ask you another question. What would this angle be? Angle EAB. 60, because it is a equilateral. Triangle AEB is equilateral. Okay, good. And then how do we find alpha? Yeah, 60 minus 45, 15 degrees. Good. Okay, let's label 15 there because that will be useful later on. Maybe useful. Let me write it properly. Okay, so what do we do after this? We're going to find phi. Anyone want to suggest? Angle ABE, yep, that's equal to 60. Yep, how would that help us? Yep. Yep. All right, you don't have to work out all the other angle. In fact, if you actually look at it, let's look at it more carefully. No, not this. Anyone else? Okay, so basically, if you look at this, let's look at this triangle. What's phi in relation to the purple triangle? Exterior angle, yes. Exterior angle is 45 plus 60, isn't it? So you say phi, should be this one. Phi equal to 45 plus 60 exterior angle of triangle AFC, right? And that's equal to 105 degrees. They take the express route. And the last one we'll leave it next time because I think we spent too much time already. Okay, that's